Welcome to my channel Adhyan with Flow. Let's start with our cardiac cycle. Okay, we all know that our heart is four chambered. Human heart is four chambered. Two short atrium, right atrium, left atrium, all right, and two large size of right ventricle and left ventricle, isn't it? We all know this. And we also know that here is lungs. Lungs take oxygen, and this oxygenated blood carried by pulmonary vein, okay, this oxygenated blood carried by pulmonary vein, and here some walls are situated. So pulmonary vein take oxygenated blood and put all the blood in left atrium, left atrium, then valve open and completely blood flow downwards the left ventricle. Same here, same here. Vena cava collect all the deoxygenated blood from the body. Vena cava collect all the deoxygenated blood from the whole body and put it into right side atrium. And here is wall also present. What they do? They pump downwards into right ventricle. Okay, I'm writing here, guys. Lungs carry oxygen dissolve into blood. So oxygenated blood carry by pulmonary vein. Why I say pulmonary? Pulmonary means lungs. These kind of veins attached with lungs. Okay, so oxygen blood carry by pulmonary vein. Now what happened next? Pulmonary vein goes towards left atrium. Left atrium put or collect blood and through pulmonary vein. Next, what happened next? Now bicuspid here, look at here bicuspid's valve, we can also call it as a mitral valve, open, and now blood goes into left ventricle. This is clear? This term is clear or not? This is clear. This is the flow chart. And now next flow chart for this side. Now vena cava collect deoxygenated blood from complete body. Okay, now put into right atrium, then right atrium collect blood, then tricuspid valve open, blood move travel towards right ventricle. This term is clear now. Now this is clear. Whatever I say, this is written here. What kind of valve is open and closed, all thing is written here. Now next important function of SAN node, AVN node. Look at here. I'm writing here. We all know that our heart is four chambered. This is the atrium, right atrium, left atrium, right ventricle, left ventricle. Isn't it, guys? Isn't it? This is the right atrium, left atrium. Okay, this is the right ventricle and left ventricle. We know that here is our SAN node is located. SAN. This is the pacemaker of heart. Clear, guys? Okay. What they do? They generate. Action potential and passes towards atria and AVN node. Clear, guys? I'm writing here. Here is AVN node situated. And what they do, SA node, what they do, they generate action potential and passes towards right atrium and left ventricle atrium, both the atria, right atria and left atria. And some impulse goes towards AVN node. This is the AVN. Okay, some impulse goes towards AVN node, some impulse goes toward right atrium, some impulse goes towards left atrium. Now what happened next? AVN, this is the reservoir pacemaker. If this pacemaker can't function, then AVN, this is also reservoir pacemaker. But there are difference. If we beat in per minute 72 times, if AVN node, they do beating time, they take 3 to 40 beating time per minute. So AVN node stimulate and generate their action potential towards the bundle of his bundle of his bundle of his. So action potential is generated from SAN. They passes their potential towards right atrium and left atrium. They passes their potential towards the AVN. AVN passes their action potential towards bundle of his, and bundle of his passes their stimulus towards the Purkinje fiber. There is a Purkinje fiber. So look at here. This is the neurotransduction, highly electrically potentially charged. So whatever I explain, everything is writing here. All right, guys, everything is writing here. I'm writing here a chart. Look at here very clearly. SAN generate action potential. Action potential. They passes their signal towards the AVN node and atria site. AVN node passes signal towards where? Bundle of his, and bundle of his transit signal towards where? Purkinje fiber. I'm giving you a chart. Remember this thing. You can solve every kind of question related with cardiac cycle. This is important, exam oriented. Atrial systole timing. How many times they take? 0.1 second. Systole means atrial contraction. Atrial contraction. Now atrial diastole, they take 0.7 second. In 0.7 second, ventricular systole present, they take 3 second. Ventricular diastole present also in 0.7 second, 0.5 second. Here ventricular systole means they contract, diastole means they relax, ventricular diastole means they relax. So we know that our average cycle is 0.8 second. Our one cycle timing 0.8 second. How we calculate this ratio? 0.8 second, because we know that per minute we have 60 seconds. Our heart beating, assume 72 times. Then we found this ratio. If anyone say their heartbeat is 100, then what you say means your one cycle timing is 0.6 second. Oh, alright. So this is the way to calculate. Yes, 0.8 second is the average. If your heartbeat is 100, then your one cycle completed in 0.6 second. If someone say my heartbeat timing is 120, then calculate their timing, calculate their cycle timing. If someone say their heartbeat is 180, calculate their timing. Easy, guys, very easy. So I clear everything. Guys. The stroke volume is 20 ml. Our heart pump this much blood at a one time. Our stroke volume. Okay. If someone say what is the atrial contraction, contribute volume. When they systole, how many blood they supply? 25 ml. If someone asks what is the value of ventricular blood inside, you have to say that 0.5 ml of blood in present in ventricle. This is atria. Okay, now what is the lub-dub sound? When our tricuspid and bicuspid valves are close, then we hear lub sound. And when our seminal values means there is tricuspid valves and bicuspid valves. Here is semilunar valves. When they close, then we hear dub sound. Means lub is tricuspid and bicuspid valve close, and dub sound is when our semilunar valves close. So this is all about what? This is all about our cardiac cycle. Now let's move further very quickly. Electrocardiograph. This is the machine, guys. This is the machine. And if I say electrocardiogram, electrocardiogram. So this is the graph when we found at a paper. This. Okay, guys. Let's start. ECG. This is the P wave. This is the P wave. When P wave is occurring, when atria depolarized. When P wave is found, when atria is depolarized. This is the P wave. And now this is the interval, and this is the low, and then up. What is this? This is the QRS, and this is the T wave. T wave indicated ventricle repolarization. What do you understand by depolarization, repolarization? I have to clear one thing. I want to clear one thing. This is the cell membrane, plasma membrane. If we want to understand what is depolarization, before depolarization, you have to understand what is polarization. This is the plasma membrane. Plasma membrane contains outside positive charge and inside negative charge. And if plasma membrane get stimulus, then this plasma membrane goes into depolarized form. Means positive ions move inside and negative ion goes outside. Look like this. Now this is the depolarized condition. Understand, guys? This is the depolarization condition. If I say repolarization, if we say what is repolarization, then again the cell become normal. Cell membrane become normal. So this is the funda of depolarization, repolarization. Isn't it? Now it's clear, guys? Now it's clear? Here, P wave, what they indicate? They indicate, yes, atria depolarized, but they indicate enlargement of an atrium. And what Q indicate? Because it's down towards. What they indicate? They indicate any kind of myocardial infarction. Means we can say that heart attack. What thing is this way? This peak, R peak, what they indicate? They indicate enlarged ventricle. Clear, guys? Are you clear with this? If I say that atria and ventricles depolarize. If I say atria and ventricle depolarize, if I use this word, then you have to understand that time that they contract. They contract. they systole. Clear, guys? So ECG, what they show to us? ECG show the timing of atrial and ventricular systole and diastole. Clear, guys? So what is the definition of ECG? ECG show that atrial and ventricular systole and diastole. What? The timing of movement, the timing of atrial and ventricular systole and diastole of the heart. Now I'm gonna make a flow chart for you for easy understanding. For easy understanding. Now first step is, now what is the first step? Depolarization of atrial, wait a minute, atrial contract. What they produce? They produce P wave. Clear? This line is clear. And add something short, atrial systole. Atrial systole. What is the timing? 0.1 second. 0.2. Now let's start. Now depolarization of ventricular produce which kind of wave? They produce QRS wave. Q is down, up, R is up, and S is again down. They take 0.2 second. Now let's move toward third point. Now ventricular systole. Systole means, what is the meaning of systole? Contraction. And this is the gap between S and T. Here, look at here. This is the gap between S and T. Here, ventricles are systole. Now next is, changing my pen, repolarization of ventricle produce T wave. And how many second? 4 second. So this is all about, this is the all about your flow chart. Okay, now let's fifth step, ventricular diastole. Now relaxing time of diastole, they take 0.6 second. Diastole means relaxation. Clear, guys? Are you clear with this? Are you clear with step? Memorize this step. They are important and very, very important for exam point of view. This is this step. This is your flow chart, their master chart to understand easily your ECG. If you remember this 5 points, you can solve any kind of question. So guys, that's all for now. In our next video, we will discuss about double circulation. Clear, guys? So thank you for listening me, giving me such a time. If you not subscribe my channel, then please subscribe my channel, Adhyan with Flow. Thank you. Thanks a lot. Keep smiling and keep revising.